Welcome back to Old School Math. We're going to continue our series on transformations. Today we're going to look at horizontal and vertical translations. By the end of this video, you'll be able to graph a function that has been translated, and you'll be able to identify the translations when a function is in vertex form. Translations are probably the most obvious transformation that we're going to look at in this unit. They're very obvious because they make an exact copy of the parent function, but they're translated or shifted left, right, up, and down. Refer to the vertex form to see where to place your vertex and draw the graph from there. The distance between the points won't change. Be careful with the x-coordinate of the vertex. If you noticed in the vertex form, it was always minus h. And what that means is it's going to be in the opposite direction of the sign due to it being negative. So if you have an x minus 3, instead of it going to the left 3, it's actually going to go to the right 3. We're going to look at a couple examples together. Now these are the examples that are on your note-taking guide, so be sure to reference it as we're working these out. Our first example is the absolute value of x minus 2 plus 3. Now I'm going to use two colors on my graph here. The original function, the parent function, is just f of x equals absolute value of x. So let's make a quick graph of the absolute value of x. We have a point at 0, 0. There's our vertex. And we can make a quick sketch from there for our absolute value of x. Now, what this transformation tells us to do is it makes us go to the right 2 and up 3. Keep in mind, our vertex form for an absolute value is x minus h plus k. So we see here, since it's minus h and it's minus 2, that means h is just 2 and k is 3. So our vertex here is at the point 2, 3. What we're going to do is find the point 2, 3 on the graph. So go over 2 and up 3. Now from this point, this graph is just going to shift up and to the right. So from here we can just draw this absolute value graph. And we can see that this is the exact same looking graph, it's just been moved to the right 2 and up 3. Take a minute and copy this down on your note-taking guide. In our next example, we have f of x equals the quantity x minus 1 cubed minus 4. Now this is a cubic function. We can tell that because of this little 3 up here. So let's look at the vertex form of the cubic function. It's x minus h cubed plus k. Now we see that this h and this negative 1 have the same sign. That tells me that h is actually 1. So our vertex here is at 1. And then the k value, the sign actually changed. So this tells us that we're going to go down 4. So that's going to be 1, negative 4. So whatever's inside the parentheses tells you to go left or right. Whatever's outside the parentheses tells you to go up or down. The only trick is if it's inside the parentheses, it's going to be opposite. So instead of going to the left one, which might make sense, minus 1, we're actually going to go to the right one. But the k value makes perfect sense. This tells us minus 4. That tells us to go down 4. So let's sketch the cubic function real quick. 0, 0, 1, 1. If we cube 2, we get 8. Negative 1, and negative 2, negative 8. So here's our cubic function. We'll zip a little curve in here, okay? And then for our translated function, we'll do it in green, and I'll underline it. We're going to move to the vertex, which is at 1, negative 4. So we'll go to 1, negative 4. And then we'll plot these points in a similar fashion. Now we see these 3 here are in a straight line. And then this one goes up 7 from there. So it'd be the point, if this is our vertex, we're going to go to the point 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So we're going to follow this same pattern. And every one of our points that we put on our original parent function should go down, should go to the right 1 and down 4. So if we wanted to do this, we could go to the right 1 and down 1, 2, 3, 4, and we could find that point easily that way. From this point to the right 1 and down 1, 2, 3, 4, and find the point that way. So we'll draw this curve in here the best we can. And this green function now is a translation of our blue function. It has the exact same curvature. It's just shifted to the right and down. In this third example, we see that we have the function f of x equals x plus 2 in the square root plus 3, or the square root of x plus 2 plus 3. So we know our parent function here is just square root of x. All right, and then let's look at our vertex form right under this. That would be f of x equals the square root of x minus h plus k. So if we want to talk about the vertex of this function, we would see the vertex would be at not positive 2, but it would be at negative 2. So that sign change, so the sign on my h value needs to change, negative 2, and then the y value doesn't change, it's just 3. Okay? So whatever that sign is with the x, we want to change it for the vertex. So let's graph the square root of x. So it starts at 0, 0, and it doesn't continue to the left. We put in 1, we get 1. When we put in 2, we get something funny. When we get 3, we put in something funny. When we put in 4, the square root of 4 is 2. And so we can see what shape this graph is making. So if we want to graph this from the vertex form, that tells us we need to go to the left 2 and up 3. So every one of these points, I'm going to go to the left 2, 1, 2, and up 1, 2, 3. To the left 2, 1, 2, and up 1, 2, 3. To the left 2, 1, 2, and up 1, 2, 3. And we can see, again, that these are going to be similar looking graphs. It's just translated to the left and up, right? If we wanted to write that transformation in here, we'd say that transformation just goes left 2 and up 3. And that would be a perfectly fine way to describe this transformation. Our next example, we've got the cube root of x plus 5 minus 4. The parent function is f of x equals the cube root of x. So you might look at your note-taking guide from the last video and see what that actually looks like, the graph of that. In vertex form, be the cube root of x minus h under the cube root plus k. So if we want to find the vertex of this, again, we change the sign that's with x, so that would be a negative 5. And the k value is minus 4. So what this tells us is our graph goes to the left 5, and it goes down 4. So every point that we put on this graph will go to the left 5 and down 4. So let's graph the parent function. I think I've been using blue for that. The cube root of 1 is 1. The cube root of negative 1 is negative 1. The cube root of 8 is 2. The cube root of negative 8 is negative 2. So here we get to see this cube root function doing something kind of like this. And then if we want to translate this to the left 5 and down 4, let's take each one of these points and let's start with our vertex this time. Let's go to the left 1, 2, 3, 4, 5, and down 1, 2, 3, 4. And then we'll follow that pattern for the rest of this graph. And here we'll go from this one down 4, 1, 2, 3, 4, and to the left 5, right there. And so we'll get to see what this graph looks like. Okay, so we see this graph is a translation to the left and down. Now, if you're following along with your note-taking guide, you've got 2 more examples on there. I actually want to fast forward through me working these and give you time to work those. So hit the pause button, work this one out, graph the parent function, the transformation, and write down what the transformation would be. I'm going to work that, fast forward through it, and you can check it in just a minute. So you can see on this example, we're just translating this thing to the right 4. I'll put a question mark out here. it's really plus 0 out there, so that's why my k value is 0. On this last example, we see 2 to the x plus 6 power minus 1. The vertex is at -6, -1. That tells us we go left 6 and down 1. Now the exponential graph is the funny graph where it doesn't have a vertex at the point 0, 0. It actually has a vertex at point 0, 1. So that's the point that I first start looking at, going to left 6 and down 1. So this would be my vertex. And the rest of these points go to the left 6 and down 1 from there. This whole graph then is translated left 6 and down 1. Well guys, I hope this video was helpful to you. There's a lot to take in when you first start looking at transformations with vertex form. Keep in mind that there are just 2 translations in this video that we watched, either left or right or up or down. I hope this was helpful to you as you keep studying transformations. Come back and watch the rest of those videos and hit that subscribe button. Thanks for watching.